Glass is one of those materials we barely notice, even though it surrounds us every single day. It holds our drinks, protects our homes, covers our phone screens, and forms the windshields of the cars we drive. It feels permanent, clean, and almost effortless, as if it simply exists on its own. But every piece of glass you touch has a hidden origin that's far more dramatic than it looks. Everything begins with something incredibly ordinary: tiny grains of sand. Every year, tens of millions of tons of silica sand are pulled from the earth, starting a transformation that turns dull particles into smooth, solid, and shining glass. Today, we're stepping inside the largest glass factory in the United States to see how this invisible raw material becomes the objects we rely on every day. History of glass. The story of glass stretches back more than 2,000 years, and surprisingly, it began by accident. Around 300 BC, early civilizations such as the ancient Egyptians were working with fire, sand, and minerals without fully understanding the chemistry involved. When silica sand mixed with sodium-rich materials was exposed to intense heat, it fused into a transparent solid unlike anything seen before. That accidental creation slowly evolved into one of the most important materials in human history. Over centuries, glass moved from rare ornaments to essential items used in buildings, food storage, medicine, and technology. What makes glass so special is its internal structure. It looks like a crystal but behaves differently. It resists heat, corrosion, and electricity, and it can be recycled endlessly without losing quality. At the same time, glass has a strange weakness. Unlike metals, it doesn't bend when stressed. It holds its shape until the moment it breaks, shattering instantly. That balance of strength and fragility is what makes glass so fascinating. Sand mining. Although glass comes from sand, not all sand is suitable. The sand used for glass must be extremely pure, with silica levels reaching nearly 99%. This type of sand doesn't come from beaches or deserts. It's mined from deep underground deposits where silica-rich rock layers are hidden. Large-scale mining operations use controlled explosions to break these dense rock formations apart. After the blast, heavy excavators collect the broken material and load it into industrial trucks. These trucks carry the raw rock to crushing facilities where powerful machines grind it down into fine, uniform grains. Even at this stage, the sand still isn't clean enough for glass production. It must go through an advanced washing process. Massive systems capable of handling hundreds of tons per hour rinse the sand using high-pressure water jets. Sieves filter out oversized particles, while spiral separators use centrifugal force to remove heavy metals. Magnetic systems extract even the smallest traces of iron. By the end of this process, the sand is pure, consistent, and ready for its journey to the glass factory. Glass bottle factory. At the largest glass plant in the United States, more than 5,000 tons of silica sand arrive every week. The sand alone isn't enough to make glass, so other materials are added. Sodium carbonate lowers the melting temperature of silica, making it easier to work with, while calcium carbonate increases strength and durability. If colored glass is needed, pigments such as cobalt oxide are mixed in to create deep blue tones. Once combined, the ingredients pass through filtration systems that remove any remaining impurities. Conveyor belts then carry the mixture to massive mixers, where every grain is evenly blended. From there, the material enters enormous furnaces heated to around 1,650 degrees Celsius, hotter than volcanic lava. Inside, the mixture slowly melts over the course of a full day. The sand loses its identity and becomes a glowing, flowing liquid. Any trapped gases escape, leaving behind pure molten glass ready to be shaped. Mold creation and bottle forming. Before shaping begins, engineers design precise molds using advanced software. Every curve, thickness, and measurement is calculated to perfection. These designs are turned into heat-resistant metal molds used on the production line. The most common method for making bottles is the double-blow process. Drops of molten glass, called gobs, are cut from a continuous stream and dropped into a preliminary mold. Compressed air pushes the glass outward, forming a hollow shape known as a parison. While still glowing hot, the parison moves to a final mold where a second burst of air expands it into its final form. This entire process takes only seconds, but it's controlled with extreme precision. Sensors and valves are timed down to thousandths of a second, allowing the factory to produce hundreds of thousands of identical bottles every day. Cooling and inspection. Freshly formed bottles emerge glowing red and are gently transferred by robotic arms onto conveyor belts. From there, they enter long cooling tunnels where the temperature drops gradually. This slow cooling is essential. If the glass cools too quickly, internal stress can cause cracks. Once cooled, the bottles move into inspection zones. High-speed cameras and optical sensors examine every surface, scanning for bubbles, cracks, scratches, or shape defects. Even the bottle openings are checked for microscopic flaws. Any bottle that doesn't meet strict standards is automatically removed. The flawless bottles continue to robotic palletizing systems, where machines stack them in perfect rows. Protective sheets are placed between layers, and the pallets are wrapped, labeled, and prepared for shipping. Sheet glass factory. Next, the process shifts to flat glass production, where efficiency reaches another level. Here, nothing is wasted. Broken glass is collected, crushed, and reused. This recycled glass is mixed with fresh silica sand and sodium carbonate, reducing the energy required to melt the batch. The mixture enters massive furnaces that run non-stop, melting the materials into a smooth, continuous flow of liquid glass. Instead of blowing, flat glass is shaped using the float method. The molten glass is poured onto a bath of liquid tin. Because glass is lighter, it floats and spreads evenly across the surface, forming a perfectly flat sheet. As it moves forward, controlled cooling zones allow the glass to harden without distortion. Robotic cutters then slice the glass into precise panels using diamond tools or lasers. The edges are polished to remove sharpness and improve safety. Finished panels are tested for strength and impact resistance before being stacked with protective layers and prepared for transport. As the flat sheet travels across the liquid tin, its thickness is carefully controlled to match the exact needs of different industries. Some sheets are made thin and light for picture frames and small windows. Others are made thicker and stronger for buildings, storefronts, and vehicle windshields. Above the glass, heaters and coolers adjust the temperature to keep the surface perfectly smooth. Special sensors constantly measure the width and flatness to make sure nothing goes out of line. If even a tiny wave or ripple appears, the system corrects it in real time. After the first cooling stage, the glass enters a long oven called an annealing layer to remove hidden stress. From deep underground sand deposits to glowing furnaces and precision machines, the journey of glass is one of heat, control, and engineering mastery. What starts as dull grains becomes bottles, windows, and panels that quietly shape modern life. Seeing what happens behind the scenes changes how you look at even the simplest glass object. If this journey sparked your curiosity, subscribe for more behind-the-scenes stories where everyday materials reveal their extraordinary paths. Stay with us and we'll see you in the next video.